when you think about today, we're looking at the eclipse all along the path from different vantage points. We've got partial here, and we've got total in some places, and we move along. That's kind of like what you guys are doing from space. You kind of get that different viewpoint. How important is that for not just Parker Solar Probe, but these other heliophysics missions?
You know, the sun is extremely complex, and the solar corona is enigmatic in many respects. So having as many measurements as possible from different locations around the sun is always insightful and will provide us more and more clues about this mysterious region of space that affects us in so many ways. So having as many eyes as possible on the sun and on the corona, it will be helpful, and the total solar eclipse is definitely one of them. So it's going to be extremely helpful for us to understand the physics of the solar corona and how it affects us here on Earth.
Now, do you look for anything special for when you watch a total solar eclipse?
This total solar eclipse, I have a wish. I hope the sun will give us the biggest show ever and give us a huge coronal mass ejection during totality. I know the probability is very low, but you never know. The sun will do what the sun will do, and let's hope we are lucky today.
Well, that brings up a good question about solar max. As we approach solar maximum, is this a rarity to see an eclipse at solar max with that maybe potential for more activity?
We've seen total solar eclipses before close to solar maximum, but we've never seen coronal mass ejection erupting from the sun. I believe during the last one there was a structure that looks like coronal mass ejection, but it was very faint. But what we're looking for is really big one, and we never seen that.
Now I want to ask you about that. So you said you saw that you almost had one. Mm-hmm. So is that a case of going back and looking at data and determining what you saw, whether it actually was really a coronal mass ejection, or do you know just looking at it with the
yeah, I think looking at it we can say, but it was small, it was faint. The sun now is at solar maximum. It can do way better than that.
Right?
Absolutely.
Now it's obviously you're going to make your closest approach in solar maximum.
Yes.
Was that planned? Did you intend to send that closest approach at a high active time for the sun?
Not really, no. I mean, I can tell you when we launched Parker Solar Probe in 2018, the sun was extremely quiet back then, and some people were asking, okay, you invested $1.4 billion into this mission, and you are launching it when the sun is doing nothing. And the answer to that is actually the perfect time to launch a mission like Parker Solar Probe. And the reason for it is the sun and the corona are extremely complex. So better to start with the basic state of the corona and try to understand it, and build on that knowledge as the complexity builds with maximum. So we started at solar minimum, now we are at solar maximum. We basically have a full half solar cycle worth of data, and it's just eye-opening for us about what the sun can do.
So it turns out you had a brilliant plan all the way along.
Let me say, it was not really planned. It was kind of coincidence, but it's a happy coincidence.
Well, and that's important for people to know. Like scientists, you don't always know when you're going to be able to launch a mission, when you're going to be able to get data. So it is really important to just make sure you get that opportunity to get the data.
Absolutely, and the sooner you get it, you just jump on it. You don't miss it, and that's the case with Parker Solar Probe, with Solar Orbiter, with basically any other mission. We want to get it up there as soon as possible. But it happens that for Parker Solar Probe, Solar Orbiter, and DKIS, and basically in a year and a half, we got the three biggest solar projects almost coming online together. Parker Solar Probe in the summer of 2018, Solar Orbiter in February 2020, and soon after that, it's Solar DKIS.
And you got a heliophysics hat trick.
Absolutely, absolutely.